The purpose of this webinar is to present qualiformed solutions for automating quality control of CYBERKNIFE treatment machines. Our solution is composed of two software platforms, QUALIMAGIQ and QUALIMAX, and a portable high-energy imager. QUALIMAGIQ and QUALIMAX softwares could also be used for modalities other than CYBERKNIFE treatment machines. But here we will focus on use with the CYBERKNIFE. You will discover that it is a very comprehensive solution, whose purpose is not just to automate a few CYBERKNIFE controls, but rather to automate and manage the entire set of quality controls for a CYBERKNIFE. Our solution includes a portable high-energy portal imager because, as you are aware, a CYBERKNIFE has two low-energy portal imagers, but only provided to control the patient's position and not radiation beams. Our portal imager is a high-resolution imager with 1024 by 1024 pixels, 0.2 mm in size, which can cover a surface of approximately 200 mm by 200 mm. This surface is quite adequate to cover the radiation beams produced by the CYBERKNIFE device. The imager also has a very extensive range of signal intensity, because the signal is coded in 16 bits with very good temporal resolution, being capable of processing 30 frames per second. Its energy range extends from 20 keV to 15 MeV, so you can imagine other applications, in particular in radiology. The imager is supplied with a power cord around 8 meters long and a shielded Ethernet cord to connect it to the QUALIMAGIQ host station. This imager can also be outfitted with covers, equipped with fiducial markers, enabling the CYBERKNIFE to detect the imager in the treatment room, as well as a dummy cover used to carry out a treatment planning on this dummy cover, which represents the imager installed beneath the treatment machine. This dummy cover can be taken to the scanner to acquire slices of an empty cover, which can be used to represent the radiation conditions of the portal imager. The QUALIMAGIQ platform is a generic platform used for medical imaging and radiation therapy in order to automate analysis of quality control measurements, DICOM images, depth of curves and profiles. Various QUALIMAGIQ modules are available to automate QA for all imaging modalities: CT scanners, MRIs, digital radiology, and nuclear medicine. In radiation therapy, the software can be used with conventional Linux as well as with tomotherapy and, of course, CYBERKNIFE devices. You will see that the workflow is very simple. 3 clicks are all you need to obtain analysis reports. There are no pull-down menus, just convenient buttons: import, analyze, and accept. The analysis yields no false positive or false negative results, because QUALIMAGIQ reads the entire DICOM header of the images imported into the program before analyzing them. That avoids to qualify a machine as defective, whereas the problem is related to QC measurements, did not follow the protocol which you decided and defined in QUALIMAGIQ. Furthermore, all of the signal extraction masks are systematically realigned on the phantom in the images. So when working with phantoms, they do not have to be aligned perfectly in order for the software to analyze them correctly. Some competitors hide this crucial point. Their solution automates the analysis, but you lose a lot of time to realign perfectly the phantom on the imager. The step-by-step mode, which enables you to see exactly how the analyses are carried out and also to parameterize the analysis methods, makes it possible for you to use QUALIMAGIQ as much more than just a black box. QUALIMAGIQ produces 6 different PDF reports, which are fully parameterisable. Of course, you can view all the trend curves you wish. The View button serves the purpose of reviewing the PDF reports and trend curves. We will be taking a close look to QUALIMAGIQ used in the framework of CYBERKNIFE quality control. A video devoted entirely to the QUALIMAGIQ platform is available if you would like an in-depth look at the platform. The first QUALIMAGIQ module designed for CYBERKNIFE treatment machines is CK Pilot. Its purpose is to pilot the image acquisition with our portable portal imager. The second module is CK Quality, the purpose of which is to automate tests of cone and iris type collimators, test of field size, circularity of radiation fields, of penumbra, symmetry, homogeneity, and in addition the capability to measure output factors. The next module, CKMLC, automatically analyzes the 2 tests carried out on a CYBERKNIFE multi-leaf collimator. The garden fence test, which analyzes the position and the width of the radiation bands created by the collimator's 26 pairs of leaves, and the picket fence test for detection of over and underdoses at the junction of the radiation bands created by the MLC. The fourth module, CK Convert, converts the images produced by the CYBERKNIFE's 2 onboard KV imagers for use in quality control of these images. These 2 onboard imagers produce images in an accurate format. CK Convert initial mission is to convert these images into DICOM format, so that the 2 modules traditionally used in quality control of digital radiography can be used. These are the EPID KV Plus module for use with a lead store 18FG or 18FL pattern, or the Normie Phantom from PTW or Primus Phantom from IBA, proposed to test images according to the German DIN norms. We also have the capability to automate analysis of those profiles measured with the Sun Nuclear Profiler supplied with the accurate installation. As these measurements have been converted by QUALIMAGIQ into DICOM format earlier on, automatic analysis is possible with QUALIMAGIQ's Those Are module. I point out here that no particular development was required for the CYBERKNIFE, as this module was already available for use with classic external radiation machines. We will now begin the demonstration of QUALIMAGIQ and these modules dedicated for CYBERKNIFE machines. Once you are on splash screen corresponding of the database scanning by QUALIMAGIQ and you would like to import quality control measurements, you will use the Import button. I recall for those of you who are not familiar with QUALIMAGIQ that the big buttons at the top of the screen follow the workflow. You first import data, then analyze it, and with a third click on the big Accept button, generate the analysis reports and the trend curves. I will begin by showing you the CK Pilot module, which operates the acquisition of the BIM images using our portable MV Portal Imager. For this, I will select the third option. Once I have selected the third option, the system proposes two types of images produced for CyberKnifes. The first option, our portable MV Imager, and the second option, the two onboard KV images. We will begin by looking at the piloting of the acquisition using QUALIMAGIQ. I select the first option and the system automatically tests the connection with our portable imager. Next, I will select an acquisition protocol. For instance, this one. And you can observe that inside of this protocol, already defined in QUALIMAGIQ, are described the set of images which will be acquired within the framework of this protocol. This will assist the user in acquiring the images because he will have only to follow the protocol which describes the QC. You can see that the selected protocol is for the MLC module, and I will now assign a name to my exam. The next step will consist in piloting the acquisition. I can see that I need to acquire 5 images and in the order indicated. I first need to acquire a picket fence image. So I initiate the acquisition and then the radiation with my CyberKnife. I note that the first image is with the MLC fully open and shows the 2 balls which describes a line corresponding to the reference for the leaf positions. The 2 balls are included in an accurate accessory attached to the collimator exit. I will add this image to my exam and then produce the second image of a picket fence test, and I will add it to my exam as well. A third image also from a picket fence test, but in the opposite direction for the MLC movement from the preceding image, in which the MLC went from the left to the right. Here it moves from the right to the left. It is important to test movement in both directions, as this impacts the results. We now get to the guarded fence tests, also tested in the 2 directions of leaf movement. I add the final image to my exam, and then I can exit the CK Pilot module, which assisted the user in acquiring the images. The exam is now on the QUALIMAGIQ platform, and you can observe that the contents are OK, indicating that the images produced are compliant with the protocol defined in QUALIMAGIQ. At this stage, I can analyze images. The 2 tests are launched, and of course, as always, here we see a screen with all of the tests, and this other screen showing only tests with problems. Tests outside tolerance. Shown here is a picket fence test in which the MLC moves from X2 to X1 with values in alert status. The next step will be to comment this quality control and then validate the comments. All of what I've just done can be performed by everyone. Acquire the images, analyze them, and leave a comment on them. However, more writes are required to accept the analysis. This is why the system requests a signature. Once accepted, the system will produce analysis reports. I will not produce the reports now because I would like to review the analysis in detail with you. So I will return to Select and enter the step-by-step mode for an in-depth view. Our objective is to present the step-by-step mode which provides a detailed view of the automatic analysis. Of course, as with all QUALIMAGIQ modules, in the step-by-step mode you can parameterize each test using these two tabs. There are two tests in this CK-MLC module. We will begin by looking at the garden fence tests. The MLC has created not contiguous radiation bands. We will test two types of MLC movement, X1 towards X2 and then X2 towards X1. QA recommends beginning by testing large deviations and then testing the moderate deviations, which is the case here. What is the limit of the large deviations? 0.95 millimeters, meaning that we will count deviations above 0.95 millimeters, and the moderate deviations are 0.50 millimeters, as defined here and here. A color code is applied, green signifying that we are below the limits and red above them. Here we are testing large deviations of the position of each leaf. That means QUALIMAGIQ tests the positions of each leaf. So with other words, it tests individually the right edge and the left edge of each irradiation band. Everything is okay. Now here the same test on the moderate deviations for each leaf. Again, movement from X1 to X2. And here the deviations for each leaf. In fact, for the large or moderate deviations for each leaf, we test one of the two edges of the radiation band produced by each leaf pair. Here we can see that it is the moderate deviation for each leaf. So here we will test the right and left edges of each radiation band to test the moderate deviations. Here this is followed by the same test but changing the direction of the MLC movement. There are two options defined by the parameter type of analysis to test leaf position. Here, with the option Positions of each slit edge, QUALIMAGIQ tests the position of each leaf. Another option is Position of the middle of the slit, where QUALIMAGIQ tests the position of each leaf pair of leaves which create the slit or the band, which means it tests the position of the middle of each irradiation band. All of these deviations are calculated relative to a reference line, which is obtained by detecting the two balls, which are supposed to be, with the accurate accessory, the zero position of the collimator. Once we have detected the two balls, we detect their two centers, which will give us a line, and all leaf positions are calculated orthogonally to this line. Next is the picket fence test. Here we test what is occurring at the junction of contiguous radiation bands to test the over and under doses. As we are dealing with those measurements, we subtract from the images an open field to remove all that is due to imager response and to beam non-homogeneity. Once we have subtracted the open field image from the tested image, we take measurements of over and under doses. Green indicates that the over and under doses are less than the alert level tolerance. Yellow color corresponds to results in alert and red results out of tolerance. Here it is tested with the MLC going from X1 to X2 and then from X2 to X1. We can note that more problems occur when it is going from X2 to X1, which points out the importance of testing movement in both directions. In terms of analysis, we have all of the tested parameters for the over and under doses and the picket fence test for each leaf pair and each radiation band. For the garden fence test, a count of the number of times the deviation is above the limit of the large deviations. The same for the moderate deviations for each leaf and also for the 2 leaf banks. We have now finished exploring the first CYBERKNIFE module for analysis, CKMLC. We will now look at the CK QUALI module, which is designed to automate tests of cone and iris type collimators. Of course, to produce images, we will again use the third option and select the portable imager, test the connection to ensure that we are in communication with the imager. We then choose the type of acquisition. I will select this one and assign a name to the exam and initiate acquisitions. This time 12 cone sizes and 12 iris sizes, for each of which we will test the symmetry, the homogeneity and the field size, as well as a test of output factor, for a total of 48 images. Of course, we will not acquire all 48 images. I will just show you a couple. I will add the first image of the protocol to the exam. And as you can see, the system rapidly tests field size to verify that it is the right cone and that the source imager distance was set correctly. We are a bit above the range, so we need to ask ourselves whether the source imager distance was respected. As it is merely an alert message, we may continue. Now I launch a second field size, which I add to the exam. Once again, the alert message concerning the distance I add to the exam and no further alert message, and I continue in this manner with all 48 images. For demonstration purposes, I will stop the acquisition and select an exam which has already been performed. Naturally, the exam is in error given that my acquisitions are not complete. This time, I will import from a folder a complete exam. For instance, this one, so that I can start the analysis. As always, I will enter the step-by-step mode to show you the complete analysis. Once again, there are 4 tests, all of which can be parameterized. You can define homogeneity, penumbra, etc. I will initiate the test of symmetry, homogeneity and field size for the iris collimators. Next, do the same for the cones. And then for the output factors for the iris and cone collies. All measurements have now been made. You can see all details of the calculations, all of the signal extractions overprinted on the images. Here we see the two output factor curves as well as all of the results, which are indicated here. This is to show you how the analysis is carried out. I will now do the same from the welcome screen. Initiate the analysis, exactly the same as previously. And once QUALIMAGIQ will have finished calculating output factors, I will be able to enter a comment on the analysis. As you recall, we can leave a comment. Here we see all of the values outside tolerance, and I can accept my analysis to produce the analysis reports. We have now reviewed the entire QA QUALITY module. Here we have the PDF reports. 6 different reports are edited. The system automatically opens the most complete report. Several options are available to the user. He may choose to highlight certain parameters. These are the parameters which appear in bold blue type on the reports. It is possible to edit a PDF report with only the highlighted parameters. The user may also decide to remove parameters which do not interest him. All of these PDF customization is of course available for all QUALIMAGIQ modules. The next module is the QA Convert module, which is in fact included in the QA Pilot module. QA Convert is used to convert in the DICOM format the images produced by the 2 onboard KV images. This time we will select the second option to work not with our portable imager, but rather with the 2 onboard images. I will select a protocol, for instance, an image quality control. Once again, I will assign a name to my exam and indicate where the images to be converted are located. The images are located here. The system requests that I confirm the date. This is the date of image acquisition. And the system then sorts the images in the order of the protocol. You know that there are 2 images and just one leads pattern, so the leads pattern appears on the first imager. On the second, there is a homogeneous image, which enables us to check image quality and signal homogeneity. The client tested 3 different KVs, in other words, 3 different exam conditions. So now, for the conversion, you have the link between the image in the QUALIMAGIQ protocol, the Accurate file which corresponds to the image and the converted image. Now, when I exit, given that it is a DICOM image, which was not previously the case, it is possible to automatically analyze these image quality tests. It is possible to leave a comment and accept the analysis. This concludes our presentation of an example of quality control of the 2 onboard images. I remind you that what we just reviewed can also be carried out with phantoms other than the leads, for instance with BTW's normie phantom or with IBA's Primus phantom. Another module is used to convert in DICOM format and to analyze automatically the dose profiles, medians and diagonals originating from Sun Nuclear's profiler, which is supplied with the CYBERKNIFE installation. we will look at an example acquired from a source access distance of 800 mm and a dose rate of 1000 monitor units per minute. I will take the 5 measurements contained in this directory and convert all of them. I now associate them with my installation. The DICOM header of the dose profiles is being constructed, as you can see here on the right, and the system discovers that certain parameters are missing. For one, the source rotation axis distance, which, as you recall, is 800, and the dose rate 1000. I will fill them in manually, as this information is missing, and now we obtain the signal conversion. The DICOM signal is in black, the measured signal in red, which is below the DICOM signal. So, if no red curve is visible, that indicates that the DICOM conversion is perfect. That means it respects your original data. Now that we have obtained DICOM measurements, I can push them into QUALIMAGIQ for analysis, the same as we would images. You notice a lot of examples outside of tolerance. I am sorry for this, it is because the tolerance level were not set. I validate my comments or I accept the analysis in order to produce the analysis reports. Same as for the leads pattern. Naturally, the most complete report is open for review. If we now return to my PowerPoint presentation. If you recall, we have taken a look at the CK Pilot module for piloting our portable MV imager. We have examined the CK Collim module for quality control of iris and cone type collimators, same as for the multi-leaf collimator, the conversion of images in Accuray format to DICOM format, for the images produced by the 2 onboard imagers, and for analysis of the leads pattern or normie or primus phantoms. And the same for the dose profiles acquired with the profiler and analysis with the DOSE-R module. Of course, we are not yet finished providing quality control solutions for CYBERKNIFE installations. We have ideas to develop complementary modules through partnerships with willing clients. For instance, automating the AQA test in order to eliminate the use of films with this test. We aim to accomplish this using a cover for our portable MV imager to replace the small phantom in which you insert the 2 orthogonal films for the AQA test. We have another project underway to use our portable MV imager as the pre-treatment QA tool, which I can outline briefly. Using measured images for beams of all collimators, MLC, cone and iris at a given distance and orthogonal incidence from the imager, and by reading the beam list from Accuray, we can calculate for each beam a predictive image based on the measured image at a certain distance and a shoot perpendicular to the imager. We will make a predictive image at another distance and another incidence. We will then accumulate all of the predictive images to yield a global predictive image, which we will compare to a measured image with gamma, chi or delta indexes. Of course, this system can only function for beams with an anterior incidence, as the imager is only capable of seeing anterior beams. But we also know that 95% of CYBERKNIFE beams have an interior incidence. To manage other simpler tests, particularly testing of safety device, of monitor unit constancy, etc. The QUALIMAGIQ platform provides the solution. The QUALIMAGIQ platform is designed not just for testing, but rather also for managing all quality control and maintenance operations on radiation therapy and medical imaging installations. QUALIMAGIQ also offers a planning function to schedule all quality control operations, and valuable accompaniment is available through the quality controls, as well as for maintenance tasks in the form of PDF documents, checklists, and video clips. As I mentioned, it includes tests for safety device and interlocks and test of the monitor unit's calibrations. QUALIMAGIQ can also manage your in-house tests that use Excel spreadsheets by extracting the necessary information to analyze results and to edit PDF reports. QUALIMAGIQ is an easy-to-use tool to assist you with your quality control every step of the way, with an interface enabling you to follow the procedures which were decided upon by your team without requiring a lot of effort. QUALIMAGIQ is also capable of managing your quality control equipment, as well as the team responsible for these quality controls and maintenance. QUALIMAGIQ contains an events journal designed to replace the written installation logs by a digital form in order to facilitate searches by entering a keyword. I could demonstrate QUALIMAGIQ, however, that is somewhat outside the scope of this presentation, which concentrates on CYBERKNIFE's installation. QUALIMAGIQ is a generic tool which can be used on CYBERKNIFE machines, but also on any type of external radiation therapy machines or QA therapy, as well as many types of medical imaging installation. Rather, I refer you to the specific QUALIMAGIQ webinar for more information. In sum, we have a very complete solution which offers all of the existing QUALIMAGIQ and QUALIMAGIQ modules. I again emphasize that our future plans include using our portable MV imager to propose a system of pre-treatment quality control. You realize that to accomplish these projects currently being developed requires partner site. I would just like to provide some information on QualiFormed and its R&D resources. The company was founded in 2006. It is totally focused on quality control in radiation therapy and medical imaging. It now boasts a very substantial knowledge of quality control and medical physics, covering the entire range of needs to automate and organize quality controls, thanks to our software and associated phantoms. Regarding QualiFormed R&D capabilities, half of QualiFormed staff are IT developers, often also qualified in mathematics or medical physics. 4 postgraduate degrees were carried out with or at QualiFormed. Taraf Torfe, Yassine Bendesh, Eloise Denis and Leon Blasi, which I cite to demonstrate that QualiFormed has the capability to continue our R&D program on CYBERKNIFE installations to automate the AQA test and make our system a pre-treatment quality control system. Please visit our website for further information on our solutions. Thank you for your attention.